Hello and welcome to this short demonstration, part of a series of videos demonstrating the IBM Rational Solution for automotive engineering. The IBM Rational Solution is a set of capabilities and best practices to help organizations develop products that must comply with the ISO 26262 functional safety standard. The solution covers areas described by the standard relating to management of functional safety, concept, system engineering and software development. In this demonstration, you will see how requirements fit into ISO 26262, along with work items, design and test artifacts, and how the Rational Solution helps you demonstrate compliance to the standard. Let's take a look at an adaptive cruise control project. In the project planning and work item management application, you can see that there is a task assigned to one of the members of the concept development team. The task is directly aligned to Clause 3.7 of the concept development phase of ISO 26262, perform hazard analysis and risk assessment. The task is to identify potential failure modes and faults that could occur, and from this information identify the safety goals and assign the automotive safety integrity levels, or ASILs. And note that these tasks have been deployed automatically from a predefined set of process templates and best practices for ISO 26262, including testing and validation, real-time dynamic analysis, and functional safety analysis. Diving into this task, you can see that it is linked to a number of other artifacts, including a set of child tasks. Let's navigate into the task Determine Safety Goals and follow it through the lifecycle. The first thing you'll see is that this child task depends on two others, performing hazard analysis, which identifies the safety goals, and determining the ASIL rating for each of those safety goals. This task also tracks a set of requirements. Using rich hovers, a common capability across the Rational Solution, you can see pertinent information about any linked artifacts without the need to navigate away from your current view. Any outputs from this task may be associated with the task itself and those linked requirements, and may also be placed under configuration control, a key aspect of compliance to ISO 26262. Let's now follow that link into the requirements management application. The linked artifact is in fact an item definition requirement, and is part of a larger document. The document gives structure and organisation to artifacts. But unlike a classical text-based document, each artifact in here is an independent entity and can be reused in other documents or projects, making them much more flexible. The document structure may be collapsed or expanded easily, saving time when navigating through larger documents. This breadcrumb reveals that the item definition requirement document itself is also part of a larger project structure. Let's follow that breadcrumb up to the top. Here you can see that all of your requirement type artifacts are organised into a hierarchical structure, enabling the requirements engineer to manage complexity. Functional, hardware, software and safety related requirement artifacts are all maintained independently for clarity and reuse, but linked together for traceability and to ensure the integrity of the work as a whole. Looking now at the Safety Goals folder, you can see the list of artifacts in that folder. And the first item in that list is the Safety Goals document, again giving structure to those artifacts. Custom views can be set up, allowing you to examine a specific aspect of the document. For example, this ASIL view shows the severity, probability and controllability of each artifact, along with a corresponding ASIL rating, which can be automatically calculated from the other three attributes. Traceability is a key requirement of compliance to ISO 26262. This traceability view shows other artifacts that are linked to these safety goals in a kind of spreadsheet view. Another way of viewing traceability is through this link explorer. The automatically generated traceability graph may be expanded or contracted manually, or automatically to any number of levels. Hovering over a node highlights that traceability path, making it much easier to visualize. Filters may be applied to the graph, allowing you to focus on specific traceability information. Applying filters to this graph shows that the original safety goal is satisfied by 3 technical safety requirements, which are in turn satisfied by a functional safety requirement. That requirement is satisfied by 2 software safety requirements in the radar subsystem. One of those is validated by a test case and has references to artifacts in the design management application. Once again, Rich Hover allows a preview of those artifacts without the need to leave the current view. Here, for example, is a functional safety concept architecture. Design management is the starting point for item definition and allows elaboration and documentation of safety analysis, safety goals and safety requirements, and ultimately the identification of the ASIL ratings. In design management, requirements may also be linked to hazard analysis models or other system elements. Clicking the test case navigates into the quality management application. Quality management provides a collaborative hub for systems and software quality across virtually any platform and type of testing. Teams can share information seamlessly and use automation to accelerate project schedules and report on metrics for informed release decisions. Users can set up suspicion profiles. When a criteria of importance changes in the requirement set, any artifact linked to it is marked as suspicious. Designers and testers can easily see if any requirement change impacts one of their artifacts. Here the test engineer can easily see which requirements this test case validates. The test case is also part of a functional safety validation plan, which has information about other test cases, along with test schedules, formal reviews, test environments and test records, and is tracked by several quality management tasks back in the work item management application. Rational engineering lifecycle management allows a holistic view, giving you access to all of your engineering information, regardless of which tool or database that information is stored in. This open approach enables engineers to query, organise and reuse engineering information from across multiple locations and sources. Better access to data raises engineer productivity, reduces time to engineer new product configurations, and of course helps improving compliance to ISO 26262. You can create custom queries to extract the data you want to see, and construct powerful views to give that data valuable context. For example, this view shows the high-level ISO 26262 tasks. Views can be connected together to allow a drill-down capability into the data you're interested in. Diving into the hazard analysis and risk assessment task shows this view, a complete traceability picture, from the initial ISO 26262 task, to the child items in work item management, to the item definition requirements, to safety goals, colour-coded and ordered by their ASIL rating, to functional, technical and software safety requirements, to the design artifacts that model them and the test cases that validate them. Also the test plans that use those test cases, and the related quality management tasks back in work item management. Once again, Rich Hover may be used and customised to provide valuable information to the reader. Views may even be dynamically updated by supplying parameters. For example, here you could choose a different ordering for the safety goals, or filter them based on level. You could even get an entirely new traceability graph by entering a new task to start from. That concludes this short demonstration of the IBM Rational solution for automotive engineering and compliance to ISO 26262.